And welcome to Technology Tap. I'm Professor JRod. In this episode, we're going to talk about post power on self-test. Let's get into it. All right, and welcome back, everyone. Hope everybody had a wonderful Thanksgiving, and welcome back. Let's finish off the rest of the year strong, right? The year's almost over. 2023 is almost in the books. We got about 34 days left as of today, November 27th, and let's finish up the year strong. So, for those of you who are listening for the first time, my name is Professor JRod, and I do these podcasts based on the CompTIA exams. I go over topics, quick questions and answers, and different stuff that comes up in the computer world as far as it relates to CompTIA and the CompTIA exam. So, like, if there's a new version of the exam coming out, I'll talk about that. If there's, if I get a hold of some questions, I'll drop them here in the podcast, and then we go over different objectives in the exam. So one of the objectives of the exam is post, right? Power on self-test. The post is a diagnostic process performed by the BIOS during the boot up sequence of a computer. The primary purpose of post is to check the integrity of essential hardware components and ensure that the system is in a suitable state for the operating system to load. And we're going to give a breakdown of the post process. Initialization of CPU. The initialization of the CPU during post involves preparing the central processing unit for operation. This process assures that the CPU starts in a known state and is ready to execute instructions. Here are the key steps involved in initialization of the CPU during post. Reset operation. When the computer is powered on or restarted, a reset signal is sent to the CPU. The CPU initializes itself by resetting its external state to a predefined starting point. Fetching reset vector. The CPU fetches the reset vector. A reset vector is a memory address where the initial program counter value is stored. The program counter is a register in the CPU that keeps track of the memory address of the next instructions to be executed. Setting the program counter. The CPU sets the program counter with the value fetched from the reset vector. This determines the starting point in memory for the execution of instructions. Initialization of registers. The CPU initializes its general purpose registers to known values. Specific registers may be set to default values or cleared to ensure a clean state. Setting flags. The CPU status flags such as zero flag, carry the flag, and overflow flags are typically set to default values. These flags are used to indicate the outcome of arithmetic and logical operations. Mode settings. Depending on the CPU architecture, the process may operate in different modes, for example, real mode or protected mode. The CPU sets its mode to initial state, determining how it interacts with memory and other system components. Initializing control registers. Control registers, which configure the various aspects of the CPU operations, are initialized to default values. These may include registers that control memory management, interrupt handling, and other systems level functions. Self-test and diagnostic checks. The CPU may perform self-test and diagnostic check during initialization to ensure that internal components are functioning correctly. Any errors detected during these checks may result in an error message or diagnostic code. By the end of the CPU initialization process, the processor is in a state where it can start executing instructions from the system firmware or bootloader. The overall goal is to establish a reliable and consistent starting point in the CPU operation, ensuring that subsequent instructions are executed correctly as part of the boot up sequence. Next, we're going to talk about memory testing. Memory testing is a crucial component of the power on self-test performed by the computer during the boot up process. The purpose of the memory test is to check the integrity of the system's RAM, random access memory. Remember, RAM is volatile memory that stores data and machine code currently being used and accessed by the computer's processor. Here's an overview of it. Memory address check. The post starts by testing different memory addresses to ensure that the RAM is accessible. It writes specific patterns of data to different memory locations and then reads the data back to verify correctness. Data bus test. The data bus is the communication pathway between the CPU and the RAM. The memory test checks the data bus by writing data to the RAM and then reading it back to ensure that the data is transferred correctly. Address bus test. The address bus is responsible for specifying a memory address. The post tests the address bus by verifying that the CPU can correctly address different locations in the RAM. Pattern test. The memory test often uses specific patterns such as all zeros, or ones, or alternating patterns to write and to read from memory. This helps identify issues with specific bits or cells in the memory. Walking bit test. This test involves writing a specific bit pattern to memory and then shifting the bit pattern to the next memory location. It helps detect stuck or faulty bits in memory. Checkerboard test. The checkerboard test alternates between writing patterns to odd and even memory address. It helps identify issues with adjacent memory locations. March test. March test involves a sequence of read and write operations that transverse throughout the memory. Tests like March C and March B are variations designed to detect different types of memory faults. Bit flip test. The bit flip test can intentionally flip individual bits in memory to check if the memory can correctly store and retrieve the altered data. And memory size detection, the post may also detect and verify the amount of memory installed to ensure the system recognizes the correct memory size. If errors are detected during memory tests, the post typically generates error messages or beep codes, providing information about the nature and the location of the memory issues. Users or technicians can use this information to diagnose and address hardware problems. A successful test is critical to ensuring the stability and reliability of the computer systems, as faulty RAM can lead to a variety of issues, including system crashes, data corruptions, and unprecedented behavior. Power supply checks. Power supply checks are an essential part of the post and overall system diagnostic. A stable and reliable power supply is critical for the proper functioning of a computer system. Here are some common power supply checks performed during post. Voltage railing monitor. The power supply unit provides different voltage level, commonly 12 volt, 5 volt, and 3.3 to various components in the system. The post may check the voltage of these rails to ensure that they are within acceptable tolerance levels. Deviation from the specific voltage levels can indicate power supply issues. Power good signal. The power supply generates a power good signal to indicate that all power rails are stable and within the specific voltage range. The system waits for the signal before proceeding with the boot process. If the power good signal is not received, the system may halt to prevent potential damage. Over voltage and under voltage protection. The power supply may have built-in protection mechanisms to prevent over voltage or under voltage situations. The post checks for over voltage or under voltage conditions and takes appropriate actions to safeguard the components. Short circuit protection. Power supply often includes short circuit protection to prevent damage in the event of a short circuit in the system. The post may check for short circuits and respond accordingly. Power supply fan check. The post may check whether the fan in the power supply is operational. A malfunctioning fan can lead to overheating, and the system may halt or generate warnings if the fan is not working properly. Power on delay. Some systems incorporate a power on delay to ensure that the power supply stabilizes before other components start operating. This delay helps prevent issues that could arise from unstable power supply during the initial moments of powering on. Load test. The post may perform load tests to check how well the power supply handles various loads. Fluctuation in power demand, such as the startup of components, should be handled smoothly by the power supply. Power factor correction check. Some power supplies include power factor correction to improve the efficiency of power usage. The post may check whether the PFC is functioning properly. If any issues are detected during the power supply checks, the post may generate errors, messages, beep codes, or other indicators to alert users or technicians about possible problems. Addressing power supply issues is crucial to ensure system stability and prevent damage to other components. If you suspect power problems, it is recommended that you consult the system documentation and seek assistance from a technician support or a qualified technician. Next is initialization of input-output devices, and this is a crucial step of post during the boot up sequence of a computer. The I/O devices include peripherals such as keyboard, mouse, storage devices, and other external devices connected to the computer. The initialization of these devices ensure they are recognized and operational. Here's an overview. Enumerating devices, the system BIOS begins by enumerating and identifying the I/O devices connected to the system. This process involves identifying the type and the location of each device. Initializing system bus. The system bus, PCI, PCIe, that connect to the CPU to various I/O devices are initialized. This involves configuring the bus and ensuring proper communication between the CPU and the connected devices. Assigning resources. The BIOS or UEFI assigns system resources such as IRQs, interrupt requests, if you don't know what that is, I/O addresses, and memory address to each I/O device. This allocation ensures that the devices can operate without conflicting with each other. Testing I/O device. The post performs basic tests on each I/O device to ensure they are functioning. For example, the system may check whether a keyboard and a mouse respond to input or if the storage device can be accessed. Loading device drivers. The system's firmware may load basic device drivers for the central I/O device, enabling communication between the operating system and these devices. How are you going to use the keyboard, right? If you want to go into the BIOS, it has to have some kind of drivers loaded, right? This is where it does it. This is often the primary step to ensure that critical devices can be accessed during the boot process. Detecting bootable devices. The systems identify and prioritize bootable devices such as hard drives, solid-state drives, or optical drives. The BIOS or UEFI determines the device from which the operating system will be loaded. Initializing mass storage devices. Mass storage devices such as hard drive or SSD drive undergo initialization checks to ensure they are responsive and accessible. The system may check the presence of a valid boot record on these devices. Initializing display devices. Display devices such as graphic cards and monitors are initialized to enable video output. The system sets display resolution and refresh rates based on the capabilities of the connected monitor. Loading expansion card firmware. If there are expansion cards in the system, for example, graphic cards, network cards, their firmware may be loaded and initialized. This ensures that additional functionality provided by these cards is available to the system. And then finally, network initialization. If the system has integrated or add-on network interfaces, the firmware may initialize these interfaces. This enables network communication, and it may involve obtaining an IP address through DHCP. So when you're obtaining an IP address from DHCP, this is where it does it at this point. Again, if any issues are detected during initialization of I/O devices, the post may generate error messages, beep codes, or display diagnostic information to indicate the nature of the problem. Proper initialization of the I/O devices is essential for successful booting of the operating system and the overall functionality of the computer system. Next, we go to boot a BIOS integrity check. The integrity check is a critical step in the power on self-test process during the computer's boot up sequence. The BIOS is a firmware that resides on a chip on a motherboard, and it provides low-level control for the hardware components on the computer. Ensuring the integrity of the BIOS is critical for the system's stability and proper functioning. Here's an overview of the BIOS integrity check. ROM, read-only memory check. The BIOS is typically stored in a non-volatile memory chip, often referred to as ROM, read-only memory, or flash memory. During the process, the system checks the integrity of the BIOS stored in ROM. This involves reading the BIOS code from memory and verifying its integrity. Checksum verification. The BIOS code is often accompanied by a checksum or hash value, which is a mathematical sum calculated based on the contents of the BIOS. The post performs a checksum verification to ensure that the calculated checksum matches the expected value. If the checksum does not match, it suggests that the BIOS code may be corrupt or modified. Digital signature, if applicable. Some modern systems may use digital signatures to verify the authenticity and integrity of the BIOS code. A digital signature is a cryptographic mechanism that ensures that the code has not been tampered with. The BIOS may contain a digital signature, and the post checks its validity. Boot block integrity check. The BIOS typically has a small portion known as boot block that is responsible for essential functions, including the initial stages of the boot process. The integrity of the boot block is checked to ensure that critical functions such as reading from storage devices are intact. Error handling. If any issues are detected during the BIOS integrity check, the post may generate errors and beep codes or displays information indicating a problem. Error messages may provide details about the nature of the issues, such as a checksum mismatch or corrupted BIOS. And then BIOS recovery, if it's available. Some systems are equipped with BIOS recovery mechanisms that can be activated if the primary BIOS is found to be corrupt. In the event of the BIOS integrity failure, the system may attempt to recover using a backup copy of the BIOS or initiate a process to reflash the BIOS. Ensuring the integrity of the BIOS is critical because the BIOS plays a fundamental role in the early stages of the boot process. If the BIOS is compromised or corrupt, it can lead to system instabilities, failures, or an inability to boot the operating system. Manufacturers often provide tools and procedures for updating or recovering the BIOS in case of issues, emphasizing the importance of maintaining BIOS integrity. Next, we're going to do expansion cards. Expansion card checks are part of the post process that occurs during computer's boot up sequence. Expansion cards are additional hardware components such as graphic cards, network cards, sound cards, and other peripherals that can be installed in expansion slots on the motherboard. The post verifies the presence and functionality of these expansion cards to ensure proper system operation. Here's an overview. Presence detection. The post checks for the presence of expansion cards in their respective slots on the motherboard. It detects the type and number of expansion cards installed. Initialization of integrated circuits. Each expansion card contains integrated circuits responsible for a specific function. The post initializes these ICs to ensure they are ready for operation. Testing for basic functionality. The post performs basic tests to ensure that each expansion card is functioning correctly. For example, a graphic card may be tested for video output, a network card for network connectivity, or a sound card for audio output. Address assignments. The system assigns addresses, interrupts, and other resources to each expansion card to prevent conflicts. The post ensures that these assignments are made correctly and do not overlap with other devices. RRQ handling, or interrupt request handling. Expansion cards often use interrupts to communicate with the CPU. The post checks the RRQ settings for each expansion card to prevent conflicts and ensure proper communications. It is very rare nowadays, ladies and gentlemen, that you get an RRQ conflict. Back in the day, it was common. Every time you put an expansion card in, you had to worry about RRQs. But nowadays, you don't. Expansion ROM initialization. Some expansion cards have built-in firmware or expansion ROMs that provide additional functionality. The post initializes the expansion ROMs to make sure they're accessible and operational. Error detection and reporting. If any issues are detected during the expansion card check, the post may generate error messages, beep codes, and display diagnostic information. Error messages help identify the specific expansion card causing the problem. Graphic card initialization. The initialization of a graphic card is a critical part of the expansion card check. The post ensures that the graphic card is operational and capable of providing video output to the display. Bootable device identification. Some expansion cards, such as storage controllers, may be responsible for connecting to bootable devices, for example, hard drives. The post identifies and verifies the presence of these bootable devices. Network interface initialization. If a network interface card is present, the post initializes it to enable network connectivity. This may involve obtaining an IP address through DHCP. The expansion card checks are important for ensuring that all components of the system are properly detected and initialized during the boot process. Any issues identified during this phase can be critical for diagnosing and resolving hardware-related problems. If there are problems with specific expansion cards, users may need to reset, take it out and put it back, or replace the card, update firmware or drivers, or address any conflict in the system's configuration. Next, we're going to go with the display test. It's a little bit more expanding on the monitor and the graphics card. The display test is a critical component of post-process during the computer's boot up sequence. This test focuses on verifying the functionality of the display subsystem, which includes the graphic card, the monitor, and related components. The primary goal is to ensure that the system can provide a video output to the display, and the display is capable of presenting information to the user. Here's an overview. Our graphic card initialization. The post begins by initializing the graphic card, which is responsible for rendering images and sending them to the display. This involves configuring the graphics card and ensuring that it's operational. Checking video memory. The post may perform a quick test of the video memory on the graphic card to ensure that it's functioning correctly. Any issues with the video memory can lead to graphical artifacts or display issues. Setting display parameters. The system configures the display parameters such as screen resolution, refresh rate, based on default settings or user-defined preferences stored in the BIOS or UEFI. Output to display. The post sends signals to the display, instructing it to show specific patterns or information. This allows the systems to verify that the display is receiving signals and can present information. Color and pixel test. The display may show a series of colors, patterns, or pixel grids to ensure that each pixel on the screen is functional. This helps identify any dead pixels or abnormalities in that display. Testing multiple monitors. If you have more than one, systems with multiple monitors may undergo tests to ensure that all connected devices are functioning as expected. This includes checking for correct detection and configuration of multiple display outputs. User interface elements. Some systems display basic user interface elements during the post, such as manufacturer's logo, system information, or diagnostic message. This provides visual feedback to the user and indicates that the display system is operational. Error messages and beep codes. If any systems are detected during the display test, the post may generate error messages, beep codes, or other visual indicators to alert the users. These indicators can help diagnose the problem with the graphical cards, monitor, or display connections. External display checks. For systems with external display connections, HDMI or DisplayPort, the post may check the functionality of these connectors and the corresponding signals. The display test is critical because it can confirm that the computer can communicate with the display hardware, providing a visual interface for the user. If the issues are identified during the test, users may need to check the display connections, test with different monitor or cable, or troubleshooting problems with the graphic cards or its drivers. The visual feedback provided during the display test is valuable for diagnosing and resolving potential display-related issues. Next we have, and this is probably going to be the last one, storage device. Storage device checks are an integral part of post-process during the computer's boot-up sequence. These checks are designed to verify the presence, integrity, and functionality of storage devices, such as hard drives, solid-state drives, and other storage peripherals. Here's the overview of the storage devices checked during post. Detecting attached storage. The post begins by detecting and identifying the storage device connected to the system. This includes internal drives, external drives, and other storage peripherals. Initialization of storage controllers. The storage controllers which manage data transfer between storage devices and the rest of the systems are initialized. This involves checking the integrity of the controller and ensuring it is ready to communicate with the attached storage devices. Checking storage device power and connection. The post verifies that the power supply and data connections to the storage device are stable and correctly configured. Loose cables or power issues can lead to storage device failures. SMART. Self-monitoring analysis and reporting technology checks. If supported by the storage device, The post may query smart data to assess the health of the drives. Smart checks can identify potential issues with the drives, such as bad sectors or imminent drive failure. BIOS UEFI recognition. The post ensures that the system BIOS or UEFI recognizes a storage device. The BIOS UEFI provides information about the connected drives and their basic configurations. Boot sector and partition checks. The post checks the boot sector and partition information of bootable drives to ensure that they are correctly configured. If the system is configured to boot from a specific drive, the post verifies that the drive contains a valid bootloader. Read-write test. Basic read and write tests may be performed on the storage device to ensure that data can be properly written to and read from the devices. These tests help identify issues with data integrity and storage device. RAID configuration checks, if applicable. In a system with a RAID, which is redundant array of independent disk configurations, the post verifies the status and the integrity of the RAID arrays. This includes checking for failed drives and ensuring that the RAID configuration is consistent. Error handling. If any issues are detected during the storage device check, the post may generate error messages. Beep codes will display diagnostic information. These indicators help identify the nature of the storage-related problem. Loading storage device data if needed. If specific storage devices are required for proper operation, the post may load these devices to enable connections between the operating system and the storage device. Ensuring the proper functioning of storage devices is critical for the successful booting of the operating system and the overall system stability. If the storage device issues are identified during post, users may need to check cables, replace faulty drives, update firmware, or address configuration problems to ensure reliable storage performance. Now, there is a couple of more. I might have to do a part 2 on this because there's not too many. There's probably like 2 left. I just don't like to do a lot. I think sometimes if I do too much, it's already, I don't want to do too much and it might bore you. So I'm going to do a part 2. I'll do a part 2 on this one day. But yeah, and it's amazing that it does all this in what? In a matter of seconds, right? 2-3 seconds it takes to do all the stuff that I just told you, right? The computer does it before the computer goes into, before you can log in into Windows, right? So it's pretty amazing that it does all this stuff. Now, all this thing is something that will be on the CompTIA exam. Some of the stuff would not be, I think in the beginning, but it was good about the CPU, but it was a good thing to learn. A lot of this stuff is on the CompTIA, the A+ exam. So it's a good foundation to know, right? And yeah. So that's going to put a wrap on this show. Thank you so much for listening. And I hope you learned something today, especially about post. Until next time. This has been a presentation of Little Cha-Cha Productions, art by Joakim, art by Sarah, music by Joakim. If you want to get in contact with me, you can. My email address is Professor JRod, JRod @gmail.com. I'm also at Instagram at Professor JRod.